Some of you have already signed in. If you haven't, if you send a message now, that'd be great. So we have a record of who's here. The first problem we're going over together is this one from the review for the final. We have a vector here. And you can read from the graph that this distance is 6, this distance is 3, you call it minus 3 because it's pointing down. So this is the point at the terminal point of the vector is 6 minus 3, and the initial point is, of course, the origin. And our job is to figure out the length and the angle. So the length is the square root of x squared plus y squared. You plug in the numbers and you get 3 root 5. And now the angle, the sine of theta, or you could do the tangent of theta, would be really pretty handy too. But the sine of theta is opposite over hypotenuse. So it is minus 3 over 3 root 5. And so that's minus 1 over root 5. And then you get out your calculator and do inverse sine of minus 1 over root 5, and you get about 26.5651. Now, let me think. They said to round this to 2 decimal places. So the proper answer on Alex is minus 26.57 degrees. Okay, anyone have a question about that before we move on? Okay, number 2, we have an equation to solve. The equation is 2 cosine squared.
Please.
Oh, you're trying to catch up?
Yeah. All right.
Okay. Anybody else need a minute? All right. Number 2 is to solve this equation. 2 cosine square x plus 5 cosine x plus 2 equals 0. And I've just copied it over up here. And this is quadratic in cosine of x. So what I'm going to do is attempt to factor it. And by the way, if you've noticed, every single one of these that we've done in this course has been factorable. It is, you could come up with a case where you'd have to use the quadratic formula, but none of those have occurred so far. So since we're past the new material, I think we don't have to worry about that. Okay, this factors this way. 2 cosine of x plus 1 times the cosine of x plus 2. The thing that tips me off to that is that I've got a 5 here and I've got a 2 here. So that means I've got to have a 2 here or here. But if I'm going to come up with 5 in the middle, I've got to have this 2 multiplying that 2. So that forces this 2 here. And then we have the middle terms are 4 cosine x plus 1 cosine x makes 5 cosine x. And of course, 1 times 2 is 2. And 2 cosine x times cosine of x is 2 cosine square x. Then you set 2 cosine of x plus 1 equal to 0. So cosine x equals minus a half. And there are 2 solutions to that. Actually, we probably think of this one first. 2 pi over 3 and 4 pi over 3. And from this one, we'd want the cosine of x plus 2 to be 0. In other words, cosine of x would have to be minus 2. Well, that's not possible. So that one you don't have to worry about. And that little comment to this equation right here, it hasn't anything to do with this graph. Another way of thinking about these graphs is this. I'm thinking of a drawing on the unit circle. Oh gosh. Unit circles are not my specialty. Anyway, a unit circle, and what I want is the cosine of x to be minus a half. The cosine is the x coordinate. So that means I have this kind of a situation, an angle here, and another angle all the way around here. So you can see that there's two solutions. And if you play a little bit with your special triangles, you'll figure out that it's the reference angle is pi over 3. So I'm going from here to here. Theta is 2 pi over 3 or 4 pi over 3. Once I know that, then I tag on plus 2k pi to both of those, where k is an integer, and I have all the solutions on the whole real line. Now, potentially, when you have an equation like this, you could get up to 4 of these solutions on the interval from 0 to 2 pi. But the reason we didn't in this case is this one factor cannot be equal to 0. So we didn't get any solutions from that. Okay, anybody need a little more time to get this down? I was just thinking that the first time I solved such equations was in the fall of 1973. So it is easy for me to go at warp speed because I have had more time to practice than most of you have been alive, which is not quite fair, but you know, most of life isn't. So all right, next one is this. We're given a triangle. We are given 2 angles and a side. So let's just label this and see where we start from. We're given that angle B, that's this one, is 101 degrees, and that's not so well written. And we're given angle C is 39 degrees, that's this one. And then, of course, you can, if you know 2 of the angles, you automatically can figure out the third one because you subtract what you've got from 180. And in this case, the remainder is 40. So that means we know exact values for every single angle. Okay, now, if we know exact angles, we know exact measures of every single angle, and we know one side. I think I might have said something stupid earlier, like there could be 2 solutions. Well, there can't, because if you know 2 angles, you know 3. And therefore, whatever side you know is included between 2 of the angles you can measure. So this is the standard way of solving this is with the law of sines. So we'll just think ahead a little bit. What do we want to solve for? We would like to solve for b. So I'll put that in the numerator, little b. B over sine of cap b, where cap b is 101 degrees, is equal to a, 16, over the sine of a, which is sine of 40. And likewise, little c divided by the sine of its angle, sine 39 degrees, is also equal to 16 over sine of 40 degrees. So in the case of the b, you multiply through by sine of 101 degrees, And in the case of the C, you multiply through by the sine of 39 degrees. That's hard to read there. It says 101 degrees. And then you just put it on your calculator. And what did they ask you? To the nearest 10th. So I'm going to round these off. Little b, I get 24.4. And little c, I get 15.7. Oh, and I should check the answers too while we're going along, because I haven't done that yet. $15.7 and 24.4. Yep. And let's check the other ones. 2 pi over 3 and 4 pi over 3 plus 2k pi. Yep. And 6.71. Oh, I had the exact value. And 26.57. Yeah, those are good. Okay, anybody need any extra time to get this one down?
I do.
Okay. Let me know when you're ready to go, Jerry.
Okay, finished.
Okay. Anybody else need a minute? Okay, question 4. Convert each of these into rectangular form. This is polar because it has r and or theta in it. And in both cases, actually, it was just one of the two variables. So I did squeeze a solution into here, but I think it might be actually better if I wrote it out again. So I can make it big enough that you can see it on this camera. So this is number 4.
This is convert to polar, right?
The other way around, convert to rectangular.
Okay.
So part A starts out this way, r equals 5. Now, if you just think about all points that have a radius, they're at a distance of 5 from the origin, well, that'd be, all the points around a circle that has radius 5. So circle radius equals 5. Center is 0, 0. Now, the way I did this one is I just know this equation, x minus h squared plus y minus k squared equals r squared. That's the standard form for the equation of a circle that has center hk and radius r. So in this case, we have center 0, 0. So you get x minus 0 or x squared plus y minus 0 or y squared equals 5 squared. So this turns into x squared plus y squared equals 5 squared, or if you prefer to write that as 25, it doesn't matter. That's fine too. Now, let me think about this. You wouldn't have to do it that way. Here's another option. R equals 5. Now use this relationship. R squared equals x squared plus y squared. So then you could say, well, instead of R, I'm going to write x squared plus y squared. And then I'd have to take the square root of that, right? Because x squared plus y squared is r squared, not r. So take the square root of that, set it equal to 5, square both sides. X squared plus y squared equals 5 squared. Same result, either way. Both are good solutions. And what I don't know is if you have not studied the standard equations for what are called conic sections, and a circle is one of them, then this one is probably not so good, because you probably don't, and you would probably use this second method. But if you do, then that's just something on tap, so you draw on it. Okay, anybody need a minute on part A? Part B says the equation is theta equals 5 pi over 6. So the idea is,
How did you get 52?
I don't have 52, I have 25.
Wait, then what's the x squared plus y squared equals 52?
Oh, I see. Yeah,
Is that
that is crummy writing is what that is, Lucas. 5 squared, which is 25. Yeah, it wasn't written very well. Sorry. Okay, find the rectangular form of this equation. Well, this equation says the angle is constant. By the way, 5 pi over 6 is just pi over 6, or 30 degrees short of pi, right? So if the angle were pi, that'd be right here, pi, and now we're 30 degrees short of that. So I had a professor once who called this derivation by eraser. and his point was, don't ever do it. So sorry, if I could remember which one it was, I would say his name, but I can't. Okay, so 5 pi over 6 is like that. And, you know, it says nothing about the radius, so it's all these points along this line. Now, here's what I would do. All the way around is 2 pi, halfway is pi. So if this is 5 pi over 6, this part in here is 1 pi over 6, which is the same as 30 degrees. So that means if we come out to just any old place, and now this line, of course, goes on. To any old place out here, we're going to have a 30, 60, 90 triangle. And you can see I didn't get my angle drawn so very well. I've got something, well, I don't know, around 40 probably. But anyway, 30, 60, 90 right triangle. And with the 30, 60, 90 right triangle, the side opposite the 30 is 1/2 the length of the hypotenuse. So if we make that 1, make this a half, and this is √3/2. Now, if you don't like fractions, of course, you can multiply them all by 2 and say this is √3, this is 2, and that's 2. But it doesn't matter. The only reason I'm doing this is I want to get the slope of this line. The slope of the line is the rise over the run, which just, I'm having a flashback here for a moment. Oh, good. I did it right. I was worried maybe I missed the minus sign when I did it the first time. Now if we label this according to the sign distances, though, this is a, this point here would not be √3/2 comma 1/2. It's minus √3/2 comma 1/2. So the run is minus √3/2. The rise is 1/2. You multiply top and bottom by 2, and you get -1/√3. Okay, so now we know the equation of a line. You could use this, or if you know the fact that the equation of a line that passes through the origin is y equals mx, you could use that. But so we know a point on the line, namely 0, 0. And we know the slope now, -1/√3. -1/√3 times x. And you definitely need the negative, because if you had a positive, then you'd have a line that goes like this. So okay, anybody want to ask a question or need a minute to copy?
What is the second one? Is it
This right here, theta
Yeah,
equals 5 pi over 6.
oh yeah, is it polar? What was it?
Oh, both of these have the same instructions: convert to rectangular form.
Okay.
And then you're given an equation in polar form, r equals 5 and theta equals 5 pi over 6. By the way, there are 2 others that I did not see in this review anywhere. Now, I think the last 10 questions I haven't done yet, but it's probably worth noting. There's 2 other equations, and that is things that are really simple in rectangular and look, definitely worse in polar. Let's suppose I had this vertical line here, and it could be anything, but let's say it crosses the x-axis at 3. Then the equation of this line is x equals 3. It's all the points whose x equals 3. How would you convert that to polar form? Well, you use use this. Unit circle, we have R. I don't like that. On the unit circle, we have X is equal to R cosine theta. And we have Y equals R sine theta. So the easy way to do this switched. So now I'm converting the other way around. So the easy way to do this switch is to replace that X by R cosine theta. And then generally they tell you to solve for R. And they may or may not simplify that to secant theta. I don't know. And of course, if you had a horizontal line, that'd be something like what, y equals -2 or y equals +7 or something like that. And then you replace y by R sine theta. If you got complicated stuff, technically you can always convert to polar because you replace all the x's by R cosine theta, all the y's to R sine theta. You may or may not be able to solve for R though. But at least you could get it in polar form. The other way around is not so simple. If you have just anything in rectangular, it's not necessarily the case that you can find a easy way to convert to polar. I said that wrong. If you start with polar, it's not always easy to get back to rectangular. Okay, so that takes care of, that gets us through problem, where are we here? Number 4. It's converting these polar equations, R equals 5 and theta equals 5 pi over 6 to a rectangular form. Anybody need to ask a question or see any of that stuff again? Okay, question number 5. We are supposed to determine the period and amplitude of the function y equals 4 cosine pi x. So what you do, this is number 5.
What is the question again?
Yeah, I'm just going to copy it out here, Luke. Y equals 4 cosine pi x. Now, the amplitude is always and forever. First of all, this only makes sense. Amplitude only makes sense if you have a sine or a cosine here. Because what that means is the maximum height of the curve above the x-axis. Well, the amplitude is 4. Now, you do have to be a little bit careful. you need to take the absolute value of that coefficient, because if I'd had, say, a -3 cosine pi x, then the amplitude, we wouldn't say that's -3, we'd say it's 3. You know, think about cosine and sine curves. They go just as high above the x-axis as they go below. So if it's maximum depth were 3, then its maximum height would also be 3. And then the way you get the period, and this works for all 6 trig functions, is, you know, you've got some, you're taking a trig function of something times x plus or minus whatever, doesn't make any difference. What you do is you take the period of the trig function, in this case, the cosine is period 2 pi, and then you divide through by the coefficient on x, 2. And since we can do it so easily, there's no reason I shouldn't show you this. Let's put in the regular, well, let's clear. Regular cosine of x. And then I'm going to put in this other guy, 4 cosine pi times x. And then I'm going to try the trig zoom. Oh, I better check my mode here. Radian is fine and function is good. Okay, zoom. Trig. Now that's the standard cosine. And notice the modified one goes way up and down a whole lot more. And it's oscillating much more frequently than the cosine. A little more than 3 times, 3.14, et cetera, times more frequently. So it's actually would probably be a bit easier to see if we zoomed out a little bit. Oh, shoot. I pushed the wrong buttons. Well, this will be easier to fix by resuming. Okay, I'm going to change my max and min y from, let's make it about double what it was, -8 to 8. And then my x scale, I'm going to put a tick mark at every 1 unit instead of every pi over 2 units. So that squashes down the standard cosine, but it should make it easier to see the period of this guy. Okay, the period goes from here to here. And if you zoom in there, I think you could just see the tick marks. There's one there and there's one there. So the period is 2. And if we could see them easily, we'd see that the maximum rise here is 3 units. So I am actually going to do a box zoom now to verify that. Something went wrong. Try again. There's a little bit of the standard cosine. That's our new function. And one, that looks like 4. Oh, it is 4. And we should have a period of 2. But this looks more like 4. Let's see if it is. Oh, no, it's not. It's putting see, we're almost at 2 right here, just a bit more than 2. And that's that 4th tick mark. It's putting a mark every 1/2 units. So it worked. Let me see if there's another one like this, because there is. Number 10 is also on the list. Got a check mark. So let me just do that one quickly. The solution is over here. Once again, the amplitude you get by looking at this coefficient out here and taking its absolute value. So the amplitude is absolute value of -2, which is 2. The period, you look at the coefficient on the x, and you take the period of cosine, which is 2 pi. 2 pi divided by 2. 2 pi divided by 2 is pi. And then the phase shift, you have to get actually by factoring this 2 out. So when I factor of 2 out of this quantity here, the 2x divided by 2 is x, but pi over 3 divided by 2 is pi over 6. And this +3 just lifts the whole graph up by 3 units. So I've got, now remember, inside the parentheses here, the shifts go opposite of the sign. So this is a plus pi over 6, which you'd write as minus pi over 6. So the phase shift is minus pi over 6. And move my cursor there. That's this. You factor the 2 out and get x minus a minus pi over 6 plus 3. Phase shift is minus pi over 6. Period, 2 pi over 2, which is pi. And the amplitude is 2. So why don't we type that one in? -2 cosine 2x plus pi over 3 and I'm going to leave the +3 off for now and go to the standard trig window. On the standard trig window, these tick marks are at pi over 2 units. So our period we're expecting to be pi, and it does look like that. this shape pretty much has repeated itself by the time you get to the second tick mark. You can see the amplitude of 2, 2 tick marks to get to the top of the curve, or 2 down to get to the bottom. And the phase shift is not obvious. However, if you think about where we think of the usual cosine curve starting at its peak, well, that is right there. And so we've got a phase shift of minus pi over 6, but the negative means it's been flipped over. So just a little bit to the left of the origin, 30 degrees, pi over 6 radians. It's been, if it weren't a -2, that'd be up here, right? So it's been shifted to the left just a bit. Okay.
Why is it
So
negative?
that was number 5 and number 10. Again, please. Lucas, I didn't get your question.
Why was it negative pi over 6?
Because the phase shift in general, if you have this form here, y equals a sine or cosine, doesn't matter. Let's put it this way, b x minus p, let me put it that way. This number is the phase shift. And the minus needs to be there in the formula. So if there's a plus here, you write it as a double negative. So the phase shift is minus pi over 6. And the fact that it's pi over 6 rather than pi over 3 is in the formula, this coefficient on the x has to be factored out. This plus 3 here has nothing whatever to do with amplitude or phase shift or period. What it does is it lifts the curve up by 3 units. So if I copy all that again, minus 2 cosine 2x plus pi divided by 3. And then I had a plus 3 here. See, it just lifts the curve up by 3 units. So not real interesting, but it does it. Okay, ready to move on? All right, back to number 6 then. Oh, my memory failed me. I told you there was none like this on the review. Well, there is. Y equals 1, change that to polar form. Well, y is r sine theta. So y equals 1 means the same as r sine theta equals 1. Divide through by the sine of theta, and you get either r equals 1 over sine theta. Wait a minute. Yep. Or you get r equals 1 times cosecant of theta. Either way is correct. I do not know if Alex would insist on one form or the other. In a lot of scientific calculations, you see people oftentimes avoiding the cotangent, the secant, and the cosecant. Not always, but oftentimes they will they would rather write 1 over the sine rather than the cosecant, just because, probably for no other reason, that the calculator has a sine button on it. And if you're doing something like engineering, you know, sooner or later, you got to turn these equations into numbers and instructions for how long to cut something, or coordinates in a of a point in a technical diagram or something like that. Okay, anybody need a little more time on this? All right, number 7. This one is a mess, crammed in there. So I'm going to copy it off on another page. But what we're supposed to do is convert this. Well, no, we're not supposed to convert. We're supposed to find an exact value for this expression here. And the way I've got it crammed in there, it's probably not even easy to read it. So let me copy it out for you, and I'll say it while I write it. The expression is the sine of 11 pi over 21 times the cosine of pi over 7 plus the cosine of 11 pi over 21 times the sine of pi over 7. And what we're supposed to do is find an exact value. It would not be difficult, whoops, misspelling. It would not be difficult to get a decimal approximation. You know, we just type that thing in our calculator, and that at least makes a way for us to check. But it's a bit of work to get there. So what I recognize, and this comes really only because I'm pretty familiar with my basic trig identities, is the sum of angles formula for the sine of x plus y is sine x times cosine y plus cosine x times sine of y. And I notice I have that pattern here: sine, cosine, cosine, sine. And then this pair of angles, 11 pi over 21 and pi over 7, stay the same on these two pairs. So that means if I set x to be 11 pi over 27, rather 21, and I set y equal to be pi over 7, then those are the x and the y in this left and right hand side, and that generates this right hand side. So let me just use that abbreviation, RHS, right hand side. That right hand side is equal to the sine of x plus y, but x is 11 pi over 21, and y is pi over 7. And now I just have to put these two together. Well, 7 times 3 is 21. So the common denominator here, is 21. Here, you don't have to do anything to it. It's just the numerator is 11 pi. And here, to get the common denominator, you multiply up and down by 3. 3 pi and 11 pi make 14 pi. And then at this point, finally, we say, aha, there's a 7 in 14 and there's a factor of 7 in 21. So divide the 7s out and I have 2 pi on the top and 3 on the bottom. 2 pi over 3. 2 pi over 3, let's see. Pi over 3 is 60. So this is 120 degrees. On sort of kind of the unit circle. 60 is like in here. 120 is about there. So I've got 60 here for a reference angle. So around here, 120 degrees, 60 degrees. So what that means is if I really have a 60-degree angle there with the x-axis, looks about like that, sort of, kind of, then $60, $90, this is forced to be 30, and we say, 30, 60, 90 right triangle, recognize that one. This side has length 1/2, and this side has length √3/2. But now let's get things signed up properly. If the origin is here, then the x-coordinate is negative and the y-coordinate is positive. Okay, so the sine of 2 pi over 3 is going to be, let's say, opposite for hypotenuse. Hypotenuse is 1, so √3/2. Yep. Okay, anyone want to ask a question or need a minute to copy? All right, number 8 was essentially a repeat of number 1, I think. So no one asked for that. Number 9, and this is our last one, because number 10, I already did that one out of order. So number 9, we're asked to solve this equation, 2 cosine theta plus 1 equals 0. Well, this one is linear in cosine of theta, so there's no factoring to do. Okay, I guess I got the solution written up here. 2 cosine theta plus 1 equals 0. You push the 1 to the other side, making it a -1, divide through by the 2. Cosine theta equals -1/2. And then you think on the unit circle, where are you going to get an x-coordinate to be -1/2? Well, on the circle, it's going to be a point here and a point here. And if this distance is half, then you want a 30, 60, 90 triangle. So if this is 60, if this is 60 here, or pi over 3, then this must be 2 pi over 3 out here. So theta is 2 pi over 3. And then, of course, there's another solution down here, which is 4 pi over 3. 3 pi over 3 is right, straight line, right? So, and the question said just to solve it on 0 to 2 pi, so we don't have to write the plus 2k pi. Okay, We have solved them all. I am going to scan this, the pages on this that we've walked through tonight. And I have a little bit of notes here where I work things out in more detail by hand. And there's another page here somewhere, but I can't put my hands on it in the moment. If I find it, I'll scan that too. And that'll appear on Blackboard along with the video of tonight's class. So you can grab it or not as is best for you. That's it.